All right, this is the third 6 weeks review for Algebra 2 Pre-AP, and we begin the review with a factoring problem where we have to factor completely. With a problem like this, we are going to use the box method, and in each one of the squares of our box, we're going to put one of our terms. So we begin with 49x to the third, and so forth. All right, once I've put each one of my terms into one of the boxes, I begin to factor out of the boxes what they have in common. All right, once I have factored out what each row and column have in common, I want to double check to make sure that I'm correct by multiplying them back together to make sure I get what's inside the box. So 7x squared times 7x gives me 49x to the third. So I know these two terms are correct. Then 7x squared times 2 is 14x squared. So I know that's right. Then I do this one, 7x times negative 5, negative 35x. And then negative 5 times 2 gives me a negative 10. So I know I have factored this correctly. The last thing I need to do is just write out my factors. All right, so 7x squared minus 5 is one of the factors, and 7x plus 2 is the other factor. Let's move on to question 2. We're going to do the same thing with question 2. All right, so as you can see, I have put each one of my terms into one of the boxes. First term goes in the first box, last term goes in the last box. These two in the middle, doesn't really matter which box you put them in. I just put them in order, so from left to right. Now all I'm going to do is factor out from each row column and from each row what these have in common. All right, so in the first column, I have, in the first column right here, I have a 5 in common and an x. Here I have a negative 3. Here I have a 3 and an x squared, and here I have a 7. And now I'm going to multiply these back and make sure I get this. So 5x times 3x squared, 5x to the third, or 15x to the third. Negative 3 times 3 is negative 9x squared. 5x times 7 is 35. And negative 3 times 7 is negative 21. So I know I have got my factors correct and I've got my signs correct. All right, so my factors are 3x squared plus 7, 5x minus 3. All right, question 3 is the difference of cubes. 64 is a cube, 27 is a cube, and m cubed is a cubed. So I'm going to use my difference of cubes formula. All right, so that's a cubed minus b cubed equals a minus b in parentheses times a squared plus ab plus b squared. This is a formula that you have to memorize. You're not going to be given this formula on the test. You have to know it. All right, so this factors out as the cube root of 64, which is 4, minus the cube root of 27, which is 3, and the cube root of m cubed, which is m. So 4 minus 3m are my a and my b. Now I'm going to square, multiply, square. So 4 squared is 16, plus multiply 4 times 3m, I get 12m, plus square the negative 3m, I get 9m squared. And that's it. That's your final answer. Now in problem 4, we have the sum of cubes. Same formula, different signs. That's the only difference. This formula is exactly the same as the difference of cubes, except here we have a cubed plus b cubed, which means our first factor is going to be a plus b, and the second part of the factor is going to be a squared minus ab plus b squared. This formula you have to memorize. Now in this particular example, we have an added step where we have to factor out of 3 in order to get cubes. If I factor out of 3, then I get 27, which is a perfect cube, and I get 125, which is a perfect cube. If I didn't factor out the 3, then those numbers would not be perfect cubes. So I have to factor out the 3 first. All right, so now we're just going to go ahead and take care of the perfect cube here. We have the sum of cubes. So the cube root of 27 is 3. So we have 3a plus the cube root of 125 is 5. So 3a plus 5, that's going to be our a and b. And then we're going to square, multiply, square that. So 3a squared is 9a squared. Multiply together, we have 3a times 5 is 15a. That one's going to have a minus sign in front. And then we have 5 squared, which is 25. And that's it. That's your final answer. Okay, so for problem 5, I'm going to read the question and then I'm going to expand the screen so I can solve the problem. Sydney took a wicked good shot on the soccer goal. The ball took off with an initial velocity of 30 feet per second. If the ball hit the bottom edge of the right corner of the crossbar, which is 8 feet high, how long was the ball in flight? All right, so we're going to write the equations first, then we're going to graph them and get some solutions. All right, so on this motion problem, we're going to use the negative 16x squared formula because this is in feet. So we have a negative 16x squared plus 30x, which represents the velocity. And I'm assuming that we are kicking this ball from the ground, so we're not going to have a height. Height is going to be 0. At the end of when the ball hits the goalpost, it hits it at 8 feet above the ground. So I write a second equation, y equals 8. And then I'm going to graph both of these equations in my calculator. And I'm going to get a parabola that's upside down. And it's going to have a line going through it at y equals 8. And what I'm looking for is this point right here. I want to know when that ball hits the goal post. How long from the time we kicked it to the time it hit the post was it in the air? And so that will give me this length of time right here in the middle. So I'm looking for this value for x. Now, after I graph that in my calculator and I analyze the graph, I find that that intersection happens when x equals 1.55 seconds. In the next problem, Logan hit a bomb over the center field fence. Logan made contact with the ball 2.5 feet off the ground, and it was launched with an initial velocity of 85 feet per second. Determine how long the ball was 60 feet above the ground. Okay, so we're just measuring when the ball was 60 feet above the ground. So we're going to write our two equations, we're going to graph them both, and we're going to find our intersecting points. All right, so our equations are going to be negative 16x squared plus 85x plus 2.5, since we're hitting the ball 2.5 feet off the ground. The amount of time that it spent 60 feet or higher in the air is going to be represented by this y equals 60. Now we graph both of those, and what we're looking for are these two intersections right here. We're looking for the x values, and we want to find the difference between these two x values to get our answer, because we want to know how long the ball was 60 feet or higher in the air. So that's what that time frame would represent. So let's see what that is. All right, so I graphed the parabola and I graphed the line, and I found these two intersecting points. This intersection was the longest time away. It was 4.52 seconds. This first intersecting point was only 0.796 seconds before the ball was 60 feet above the ground. So what was the difference between these two? That was 4.52 minus 0.796. That gave me 3.724 seconds. All right, in problem 7, I want to factor completely. So I'm going to factor out the y first, and then I'm going to factor what's left. So let's factor out this y. And we have 36 y squared minus 16. Now you should recognize that these two numbers are both perfect squares, and so is y squared. So what we have here is the difference of squares. So that's going to factor 6y minus 4, 6y plus 4. That's all. So problem number 8 is essentially the same thing. I'm going to factor out an a, and then I'm going to factor the difference of two squares, which is what's left after I factor out this a. So I get 4 minus 10a, 4 plus 10a. Made a little mistake there. That should have been 16 minus 100a squared. So now that's how that factors, and we're done. All right, in the next problem, we solve each system. First thing we need to do is set these both equal to y, and then we're going to set them equal to each other. All right, so I set the first equation equal to y, and I got y equals x squared minus 4x plus 6. And then here's my second equation. Now I'm going to set these two equal to each other. X squared minus 4x plus 6 equals x plus 2. And now I'm just going to set this equal to 0 and solve for x by factoring. All right, so I have set this equal to 0, and I factored it, and I got that x minus 1 times x minus 4 gives me x squared minus 5x plus 4. And when I solve for x for each one of those, I get x equals 1 and x equals 4. Now those are my x values for my solutions. Now I need to find the y values. So I'm going to plug those values in for x into y equals x plus 2. That's the easiest one to do. And when I do that, I get y equals 1 plus 2 is 3, and y equals 4 plus 2 is 6. So my two solutions are 1, 3 and 4, 6. And I'm going to check this by graphing these in a graphing calculator. I can graph these two equations together and find the intersecting points. The intersecting points should be 1, 3, and 4, 6. We're going to do the same thing with number 10 that we did with number 9. All right, so we set both of these equal to y equals. So I had to move the 17 over. I got x squared minus 11. Then I set them equal to each other. X squared minus 11 equals 3x minus 7. Then I moved everything over to make it equal to 0. So we set this equation equal to 0. X squared minus 3x minus 4. I can then factor this equation, x minus 4 times x plus 1. I then solve for x for both of these factors. I get x equals 4 and x equals a negative 1. I plug these values for x back into this linear equation. I get y equals 5 and y equals negative 10. So my solutions are 4, 5, and negative 1, negative 10. Again, you can graph these two equations together in your calculator, find where they cross, find their intersecting points. When you do that, you should get 4, 5, and negative 1, negative 10. All right, in problem 11, we're solving using the quadratic formula. So the first thing we need to do is set that one equal to 0, and then we can use the formula to solve for x. All right, so on this problem, we set this equal to 0 first, and then we use the quadratic formula. So x is equal to a negative b, and since 6 is already negative, that means that this 6 here in my formula is going to be positive. So minus a negative is plus, so we're just going to leave that as a positive. Plus or minus the square root of negative 6 squared. Negative 6 squared is 36. Minus 4 times a, which is 9, times c, which is negative 4, all over 18, which is 2 times 9. All right, so now we got to simplify this. I'm going to simplify this discriminant right here. This is going to be 180. That's what I get right here. And now I need to simplify this radical. I find out what perfect square in here I can take the square root of. Well, I found that 36 times 5 gives me 180. So I take the square root of 36, that gives me 6. So that's how I got 6 root 5. So the square root of 180 is 6 root 5. Now I simplify what I have left. Since all of these numbers are divisible by 6, I can reduce this. So I reduce all of these to 1s, I reduce that to a 3, and I get 1 plus or minus root 5 over 3 is my final answer. All right, so in problem 12, we're going to do the same thing. We need to set this equation equal to 0 before we can use the quadratic formula. All right, so here we did the same thing. I took the negative 4 here and I made it positive because x is equal to negative b. So if this b is already negative, then this b here is going to be positive. So 4 plus or minus the square root. Negative 4 squared is 16 minus 4 times a times c. So 4 times 2 times 12 times 2. All right, all over 2 times a, which is 12. So that's 24. All right, so now we simplify. We get 4 plus or minus the square root of negative 80. Here I'm going to end up with an imaginary number, all over 24. Well, I know that 16 times 5 is 80, so I'm going to take the square root of 16, and that's going to give me 4. I'm also going to take this negative sign out of my root, and I'm going to make that an I. So I have 4 plus or minus 4i root 5, all over 24. Now this 4, and this 24 all reduce. So I'm going to reduce this to 1 over 6. So 1 plus or minus I root 5 over 6 is my final answer. All right, problem 13 and 14 are both area problems, and we don't have a lot of space on our paper to work out our problems, so I'm going to expand this page really big so I've got plenty of room to draw some pictures and write out some equations. Now, the first equation is a rectangular field is 300 yards by 500 yards. A roadway of width x yards is to be built on the inside perimeter of the field. Find the value of x, which makes the roadway have an area equal to the inside of the field. Now, that's huge, but it gives me enough space to draw pictures. So I'm going to start with a rectangular shape that's going to represent my field, and my field is 300 by 500. So I'm going to put 300 on this side and 500 on this side. Now I'm supposed to make a road inside the field and the inside perimeter. So my road is going to be out here. Well, this is my 300 times 500. So my entire area is 150,000. So that 150,000 represents the entire area of this whole field. All right, so what I need to know is what value makes this. I'm going to erase this area right here, because this area right here, the entire field is 1,000 or 150,000. So that's the entire area. So I'm going to just write that down. A equals 150,000. Okay. So what we need to do is we need to try to find the value for x, which is we want to know how wide the road is. Okay, well, we know that if we take our 300 and we subtract 2x and we multiply that times 500 minus 2x, that will give us this area in here, which is going to be half of the whole area, because this area is the same or equal to this area out here. So if those areas are the same and the whole area is 150,000, then the area for the inside is going to be 75. So we need to write that in here. Let's write that in here. 75,000. That's important because we have to set this problem up correctly. Otherwise, we're going to get the wrong answer. All right. All right, so I've got my two equations. It's 300 minus 2x times 500 minus 2x minus the 75,000, which represents this area inside in the middle. If we set that up, we should be able to find our value for x, which is going to give us the width of our road. All right, so when I set that into my calculator and I solve for x, I get that on the x-axis, my parabola crosses at 54.2 yards. So that is going to be the width around my field. Okay, in the next problem it says Mrs. Vaca is running for the school board seat for her area. She has a billboard with her picture and the slogan, Team Vaca, the right choice for a winning team. If the billboard is 14 feet by 48 feet, and her poster is inside those dimensions with a uniform width border, and her poster having an area of 581.25 feet squared, find the width of the border. Okay, so we're going to set this up just like we set up the other problem. All right, so here we have a picture drawn of the billboard. It's 14 feet by 48 feet, and the area of Miss Vaca's picture is 581.25. So what we're trying to find is this value for x. Now we know that if we subtract 2x from each one of these sides and we multiply them together, that we will get 581.25 feet. So we really don't need to know that the total area of the billboard is 672. We don't really need that information, so we're going to leave it out. But I'm going to go ahead and set up these two equations and then we're going to graph them. All right, so the equation is 14 minus 2x times 48 minus 2x equals 581.25x. Now when we graph that and we solve for x, we get 0.75 feet. And 0.75 feet is about 9 inches. So if you wanted it in feet, you could say 0.75 feet, or if they want the answer in inches, we could say about 9 inches. And that's it. Okay, problem 15, we are finding the discriminant, and the discriminant is basically just b squared minus 4ac. That is the part of the quadratic formula that's underneath the radical. So we're only looking for that piece of our quadratic formula. Before we can do that, though, we need to make sure that our equations are set equal to 0. All right, so after I set this equation equal to 0, I get negative 4n squared minus 2n minus 3 equals 0. Now I'm ready to find my discriminant. Notice how I put all of my numbers in parentheses. We have a lot of negatives here, so if you're not careful, you could end up getting the wrong number because you didn't use parentheses. When you take negative 2 and square it, that gives you a positive 4. So just make sure that when you are doing this, that you don't make any sign errors. Then after you put the rest of these in, you're going to find that you get the number negative 44 as your discriminant. And that is it. All right, so we're doing the same thing with problem 16. Set it to equal to 0 first, and then find the discriminant. All right, so I set my equation equal to 0. I use my formula b squared minus 4ac. I get 11 squared minus 4 times 5 times 6. And when I combine this in my calculator, I get the number 1. Okay, problem 17, we're converting to vertex form by completing the square. So I'm going to write down all the steps and discuss them as after I've gotten them written down. All right, I'm going to take you through this one step by step. First of all, I added a 46 to both sides to isolate this part of my equation. because this part of my equation is what I'm going to use to complete the square. I need to get this number out of my way. So I go ahead and I move it over. The next thing I'm going to do is take the part of my equation that I'm going to make a perfect square, and I'm going to factor out whatever's in front of this x squared, because in order to complete the square, this x squared needs to be by itself without any other coefficients besides 1. So I'm going to factor out the negative 2. I factor out the negative 2 and I get x squared minus 10x plus, and then I'm going to leave a blank to complete my square. That's going to equal 46 plus that same blank times this negative 2 that I factored out. So I'm going to make sure I've multiplied whatever this number is by negative 2. Next, I'm going to complete my square. I have x squared minus 10x. I need to take half of this and square it. Half of negative 10 is negative 5. Negative 5 squared is 25. Next, I'm going to add that 25 over here. These blanks are the same. So plus 25 plus 25. Then I simplify. So this negative 2, I'm going to rewrite this as a perfect square. So I know this is x minus 5 times x minus 5. That's my perfect square. So x minus 5, the quantity squared, is going to be this right here, rewritten as a binomial squared. Here's my perfect square. That equals, and when I simplify this, I get a negative 4. Now I'm ready to write my equation. Y equals negative 2 times the quantity x minus 5 squared. I move this 4 to the other side, plus 4. And that's it. That's my equation written in vertex form. We're going to do the exact same thing with question 18. All right, so here it is. We have isolated this 3x squared plus 48x by moving the 196 to the other side of the equal sign. Now I'm going to expand this out. I'm going to factor out the 3. I get x squared plus 16x plus a blank equals negative 196 plus the same blank times 3. Now I'm going to complete the square here. Half of 6 is 8. 8 squared is 64. So I'm adding 64 to each one of the blanks. Now I'm going to rewrite my trinomial as a binomial squared. Half of 16 was 8, so it's going to be x plus 8, the quantity squared. That's going to be my perfect square. And I simplify this down to negative 4. Now I'm ready to write my equation. Y equals 3x plus 8, the quantity squared, plus 4. We move the 4 over here. That gives us plus 4. And that's it. Okay, the next problem, we're writing the equation in standard form. All right, the key here is to go ahead and expand your binomial to x minus 3 times x minus 3. Go ahead and FOIL that first. The next step is to distribute the 1/2. So distribute the 1/2 before you add the 3. So when I distribute the 1/2, I get 1/2 x squared minus 3x plus 9 over 2 plus 3. And then I just combine my like terms here on the end, the 9 over 2 plus 3. And I get y equals 1/2 x squared minus 3x plus 15 over 2. And we do the same thing with problem 22. All right, so we broke this apart into its two binomials, x minus 5 times x minus 5, FOILed it together. We got x squared minus 10x plus 25. We then distributed the 3x squared minus 30x plus 75, and then subtract the 6. And we get y equals 3x squared minus 30x plus 69. That's standard form. All right, in the next problem, we're solving the inequality. So we want to set this one equal to 0 first, and then factor. Now on these, I like to factor using the box method. So the way I do that is I put the 2d squared in the first box and the negative 12 in the last box. And now I'm going to find the factor pairs for 24, because 2 times 12 is 24. I want to find the factor pairs for 24 that add to give me 5, and I find those to be 8 and 3, with the 3 being the negative one. So 8d and negative 3d. And now I'm going to factor out of the box. Well, this one has a D in common. This one has a 4 in common. This one has a 2 and a D in common. And this one has a -3. So my factors are 2D minus 3 and D plus 4. And now I'm going to set those equal to 0 because I want to find my critical points that are going to be on my number line. So I'm going to set each one of these equal to 0 and solve for D. So I have D equals 3 over 2 and D equals -4. Those are going to be my critical points. Now I'm going to draw a number line so I can put in my critical points, -4 and 3/2. I'm going to put a 0 in here, and I'm going to put my 3/2 about right there. And since it's less than or equal to, I know that these are going to be solid dots. And then I'm going to plug a 0 in to see if this statement is true or not. So when I plug a 0 in right here for D, I get 0 plus 0. So if 0 is less than or equal to 12, then I know that I need to shade where 0 is. So since that's true, I know that that's where I'm going to shade. So I'm going to shade here. So I could show my solution as this number line shaded in, or I could show my solution as X, or D, I should say, this is D. D is greater than or equal to -4, or D is less than or equal to 3/2. So either one of those ways to express my solution is fine. So problem 24 is the same kind of problem, so I'm going to go ahead and work that out, and then I will explain what I did. All right, so first of all, I set my equation equal to 0 so that I could factor it. And then I factored it. I used a factor box. I put my 4x squared in the first box, and then I put my 8 in the last box. 4 times 8 is 32. The two numbers that multiply to give me 32 to add to give me 33, of course, are 32 and 1. So those are my two middle terms, -32x and 1x, and they're both negative. Okay, this is a -33, so these both need to be negative. So -32 and -1. Then I factor them out. The thing that these two boxes have in common are the x. This one 8, this one the 4x, and this one just a 1. These both have to be negative. So my two factors are 4x minus 1, x minus 8. Then I set them equal to 0 and solve for x to get my critical points. For the first critical point, I get 1/4. For the second critical point, I get 8. Then I put them on a number line with a 0 here. So this one is 1/4. It's really close to 0, so that's 1/4 with an open circle. This one is 8 with an open circle. Since it's greater than, it's not equal to. And then I plug 0 in to check to see if the statement is true. So if I make this 0 and I make this 0, then 8 is greater than 0. So I'm going to shade where the 0 is, which means I'm shading on the outside. So I'm shading out here, and I'm going to shade out here. Now another way I could write these solutions would be that x is less than 1/4 or x is greater than 8. So those would be the solutions. And that's it. All right, so for the next problem, we are writing the equation of the graph in vertex form. So we need to find the vertex. And so we find it to be right here. And then we need to find another point as well on our graph. So I'm going to use the y-intercept. And from those 2 points, I'm going to write my equation in vertex form. All right, so for the first step, I am writing down my vertex, which is -1, -2. And then I write my equation in vertex form, y equals a times x plus 1. Remember, we got to change the sign. The quantity squared, don't forget the square, minus 2. That's a minus 2. Then we're going to use the other point that we picked, this y-intercept point, which is 0, -4 to find a. So we plug -4 in for y, we plug 0 in for x to find a. Okay, so when I plugged in my -4 and my 0 for my x and my x and my y, I simplified this to a because 1 squared is just 1, so that's just 1a minus 2. Then I add 2 and I get -2 equals a. Now I'm ready to write my equation because I have all my pieces. So my equation is going to be y equals -2 is my a value. Then I come back up here and I pull this right here as the rest of my equation. So I'm going to write x plus 1, the quantity squared, minus 2. And that's it. All right, so problem 26 is just like problem 5. So I'm going to find 2 good points first. Of course, I need my vertex. That's an important point. And then I'm going to find one other point where the parabola crosses. And it looks like right here is a good point. So I'm going to use the point 43 as one of my points. And I'm going to write my equation in vertex form. All right, so I used my vertex 1, 6 to start my equation. And here I have a times x minus 1, the quantity squared plus 6. And then I'm going to substitute in this point right here for 3 and for x and y to find a. So 4 minus 1 is 3. 3 squared is 9. So I get 9a here plus 6. Then I subtract 6. I get -3 equals 9a. Then I divide by 9, I get -3 over 9, which is -1/3. So my a value is -1/3. Then going to take that value to write my equation. So -1/3, and then I'm going to come back up here. I'm going to pick the rest of my equation right here, which was x minus 1 squared plus 6. I'm going to write that down here. X minus 1, the quantity squared, plus 6. And that's it. That's my equation in vertex form. Okay, for the next one, we are going to write the equation in standard form using the points on the graph. All right, for this one, we're going to set up a system. So we're going to set up a system using each one of these points. We're going to write a different equation for our system. So we start with the first one, and we write 15 equals, and then we need to take our x value and square it. So that's going to be 100a plus, and then we're just going to use x as it is, 10b plus c. That's going to be our first equation for our system. The next one, I take my next point and I write -3 equals, I square 7, 49a. Then I add my 7b plus c. The third point is going to be 5 equals, and then I'm going to square the 9 as 81a plus 9b plus c. Now I'm going to enter that into my calculator under solving matrices, which is under the algebra menu, and I'm going to solve for a, b, and c. Now in the calculator, this is actually x, y, and z, don't forget. So when you're entering these equations, you're not going to be entering them as a, b, and c. You're going to be entering them as x, y, and z. So make sure you change your a's to x's, your y's to b's, and your c's to z's when you're entering it in the calculator, because it reads x, y, z. All right, so when I solve the system, I get these solutions. I get 2, -28, and 95. So the way I'm going to write my equation is like this. Y equals 2x squared minus 28x plus 95. Now the way I can check to make sure that this is correct is I can graph this in the calculator and check the table. when I check the table, I want to make sure that these points are on the table. If these points are not in my table, then this is not correct and I need to go back to see if I made a mistake, probably with a sign somewhere. So just make sure you check that at the end to make sure that you've got these points in your table for this equation. Okay, so for problem 28, we're doing the same thing. All right, so notice that in this one, all of my middle terms are negative. So make sure that you're very careful when you are setting up your equations. If your x is a negative number, and in this one, all of the x's are negative, if your x is a negative number, your middle term is going to be negative when you put it into your system. So be careful, watch out for that negative sign. So when I put this in my calculator, I get my x, y, z as 2, 16, 37, and now I'm ready to write my equation. Y equals 2x squared plus 16x plus 37. And that's it. Now in problem 29, we have to set these zeros equal to x, because that's what we got when we got the zeros. We got that x equals a negative 1/3 and x equals 8. And now what I need to do is rewrite these zeros as factors. Well, in order to get that 1/3, I had to subtract the negative 1 and divide by 3. So what I'm going to do is the opposite. I'm going to multiply by 3, which means I'm going to put a 3 here. And I get 3x equals negative 1. Now I need to add the 1. So that's one of my factors. The other factor is easy to get because all I have to do is subtract 8. And that's my other factor. Now what I'm going to do is multiply these two factors together to give me the standard form. So basically I'm foiling this. And after I FOIL it, I'm going to have my standard form equation. My standard form equation is y equals 3x squared minus 23x minus 8. And I can check that by graphing it and making sure that these zeros, negative 1/3 and 8, are where my parabola crosses the x-axis. And as long as that happens, then I know that I have the correct formula in standard form, or correct equation in standard form. All right, so we're going to do the same thing with problem 30. Okay, so here we set these zeros equal to x, and then just added 6 to both sides here. I got x plus 6 as one of my factors. The other factor, multiply by 3, that gives me 3x. Add the 7, 3x plus 7. Now multiply these together to get the standard form. You get 3x squared plus 25x plus 42. This is in standard form. And that's the end of the review for the third 6 weeks test. I wish you a lot of luck. Come to tutorials if you need help, please. I'll be here all week. I don't have to be anywhere else except for Wednesday after school. So just come to tutorials and I will be happy to help you out.